Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to optics and the chapters of lenses and formation of images. This exercise was a previous one in the brevet exams in 2005, second session, first exercise. The title of this exercise is Exploitation of a Document Concerning a Converging Lens. The document below, they mentioned the document, so now I can use it. Represents a converging lens L, its optical axis x prime y x, luminous object AB, and screen E. So part A, construction of the image A1B1 of the object AB given by L. So the image A1B1 is formed on the screen. Number 1. They are telling me redraw with the same given scale the above document. So notice that here the direction of propagation of light is not indicated, but we take it as in the same direction of the positive x-axis, which is from left to right. So this is the direction of propagation of light. And whenever we need to redraw, we always start by drawing the optical axis at the center, having the same direction of propagation of light, which is from left to right. So this is x prime, and this is x. Then we place the lens L perpendicular to the optical axis at the center, using the correct symbol of a converging lens. And the intersection between the optical axis and the lens L is the optical center O. Now the point A is located on the optical axis in front of the lens, 3 divisions away from L, so 1, 2, 3. And the point B is located 1 division above A hat is found on B, so this is the object AB. Moreover, the screen E is located behind the lens perpendicular to the optical axis. So the number of divisions between L and E are given by 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Then this is the screen E. Finally, the scale along the x-axis is given by 5 centimeters, and along the y-axis is given by 2 centimeters. Then this is it for number 1. Now in number 2, they are telling me specify with a justification the position of the image A1 of A. Then here, because they are telling me specify with a justification, then we need to trace the image and justify it. So notice that here, because the point object A is on the optical axis, then the point image A1 will be on the optical axis, and we already know that the image A1B1 is formed on the screen. Then the image A1 is on the optical axis and on the screen E, therefore it's the intersection between the optical axis and the screen E. So this is the position of A1. Now let's justify. Since the object is on the optical axis, then its image will be on the optical axis, and we know that it is collected on the screen. For this reason, then the image A1 of A is the intersection between the optical axis and the screen. Now in number 3 they are telling me trace with the necessary explanations the path of one luminous ray which allows determination of the position of the image B1 of B. So here they are telling me the path of one luminous ray which allows the determination of the position of the image B1 of B. Then because they told me trace with the necessary explanations, that we need to trace and justify this ray, and we need to trace the image and to justify it as well. Okay, so the path of one luminous ray, because we need to determine the position of the image B1 of B, then this ray must be issued from B. Now we know how to draw 3 particular rays issued from B, but in this case we don't know the position of the object focus and we don't know the position of the image focus. Therefore the only ray that we can draw issued from B is passing through the optical center, and we know that this ray will emerge without deviation. So this is the tracing of the path of one luminous ray. Now let's justify it. Here we are in number 3. Then the justification of this ray is given by an incident ray issued from B passing through the optical center. Emerges without deviation. Then we have done the tracing of the ray and the justification. Now we need to trace the image and justify it. So because the point B belongs to this incident ray and this emergent ray is coming from this incident ray, then the image B1 of B will belong to this emergent ray, and we already know that the image is being collected on the screen. Therefore the point B1, which is the image of B, will be the intersection of the emergent ray and the screen. Moreover, a hat is found on B directed away from the optical axis like this. Then we must place a hat on B1 directed away from the optical axis like this. So this is the hat. So this is the tracing of the image. Now let's do the justification. What does the point B1 represent? Then the image B1 of B is the intersection of the emergent ray with the screen. So this is the justification and done for number 3. Now in part B they are telling me characteristics of the image A1 B1. In number 1 they are telling me give the nature of A1 B1 and find its length. So let me make some space. Now we are in part B, number 1. So nature Now here, because the image A1 B1 is being collected on the screen, and we know that only a real image can be collected on the screen, then let's say since it's collected on the screen, then the image A1 B1 is real. One could give another reason why the image is real. The first one is that because the object and the image are on opposite sides, and another reason is given by that the image is inverted with respect to the object, because the object AB is pointing upward and the image A1 B1 is pointing downward, which means that the image is in an opposite direction with respect to the object AB. And now let's say find the length of the image A1 B1, or in other words the size So now A1, B1 consists of two divisions, and we multiply by the scale along which you have counted the number of divisions, which is scale along the y-axis. So this will give me 4. Since the scale is in centimeters, then the value of A1, B1 will be in centimeters. So A1, B1 is equal to 4 centimeters. Always all quantities in physics must have unit. Finally, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. Now in number 2, they are telling me is the image A1, B1 erect or inverted with respect to AB. So in other words, they are asking me about the direction of the image. So we have already said that the image is inverted with respect to the object AB. So the image A1, B1 is inverted with respect to the object AB. And now in number 3, they are telling me find the distance D is equal to OA1 between the lens and the image. So number 3, distance between L and A1, B1 this distance is denoted by D, which is the distance between the lens and the image A1, B1, and it consists of 1, 2, 3, 4, 5, 6 divisions. And we multiply by the scale along which I have counted the number of divisions, which is scale along the x-axis. This will give me 30. Since the scale is in centimeters, then the value of D will be in centimeters. So D is equal to 30 centimeters. Now in part C of this exercise, they are telling me determination of the focal length of L. Number 1, they are telling me trace with the justification the path of the luminous ray, which allows determination of the position of the image focus F prime. So using a certain ray, we need to determine the position of the image focus F prime. And here they told me trace with a justification, so we need to trace the ray and justify it, and we need to trace the image focus and justify it as well. And this ray must be issued from B. So we know that always that incident parallel ray is related to the image focus. Therefore, if we consider an incident ray issued from B parallel to the optical axis, and we don't forget arrows on light rays. Now in this case, this ray will emerge passing through the image focus, but yet we don't know the image focus. Therefore, this ray will emerge going to the image B1, because we know that all incident rays issued from B emerges going to B1. So this is the tracing of this ray. Now let's do the justification. An incident ray issued from B parallel to the optical axis So this is the justification of the ray. Now let's trace and justify the image focus. Because this emergent ray corresponds to this incident ray, which is parallel to the optical axis, so this emergent ray will pass through the image focus, and we know that the image focus belongs to the optical axis. Then the image focus will be the intersection of this emergent ray with the optical axis. So this is the tracing of the image focus, which is denoted by F prime. Now let's do the justification. Then the image focus which is denoted by f prime, is the intersection of the emergent ray with the optical axis. And now in number 2 they are telling me deduce the value of the focal length half of L, and the word deduce means that we need to use the part just previously before. In number 1 we have determined the position of the image focus, and we already know the position of the optical center, so therefore we can calculate the focal length by referring to its definition, which is given by the focal length is the distance from the optical center to the image focus. Now let's calculate the focal length, which is denoted by f, and it's equal to the distance from the optical center, which is the point O, to the image focus, which is the point f prime, and we don't forget the bar because this distance may be positive or negative. So now f is equal to O f prime bar, which is the distance from O to f prime. Notice that this distance in the same direction, it is in the same direction of the positive x-axis, so it's positive. And the number of divisions between O and f prime is 2. And we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. So this will give us 10. Since the scale is in centimeters, then the value of f will be in centimeters. So f is equal to 10 centimeters. So the focal length in this case is positive, which verifies that the used lens is a converging lens, because we know that for a converging lens the focal length is always positive. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.